There are transmissions that clarify mysteries, transmissions that confirm theories, and then there are transmissions that break everything. Transmissions that force scientists to freeze mid-sentence, stare at the monitors in silence, and ask themselves if humanity has just crossed a line it was never meant to cross. Voyager 2, drifting alone through the deep vacuum for more than 46 years, has just sent one of those transmissions. What came through the deep space network this time wasn't like the plasma hums, the solar echoes, or the interstellar shocks we've heard before. This transmission carried patterns, structured, layered, rhythmic pulses buried inside the faintest whisper of radio energy traveling more than 12 billion miles through the void. And what's worse, this new signal came after Voyager 2 lost contact for 7 months, after NASA realigned the antenna against impossible odds, and after every instrument on board was pushed beyond its original lifespan. It came when Voyager should have been silent. It came from a place where no spacecraft has ever remained stable. It came from a region where even the sun's influence collapses and the galaxy's true environment begins. And the tone of the mission team says it all. Voyager 2 did not just send data. It sent something that feels like a warning, a whisper, or a message from deep space itself. Tonight, we travel from the launch of the twin probes to the moment this new transmission reached Earth. And we uncover why this one fragment of radio energy has left NASA terrified, fascinated, and unable to explain what Voyager 2 has truly encountered. Before we can understand the transmission, we must understand the origin of the machine that sent it. And that origin begins with an alignment so rare that it happens only once every 176 years. Back in 1965, when space exploration was still a dream more than a discipline, Gary Flandreau, a graduate student armed with nothing more than a pencil and an instinct for orbital mechanics, stumbled upon a cosmic configuration that would change human history. Jupiter, Saturn, Uranus, and Neptune, the 4 giants of our solar system, were slowly drifting into a perfect gravitational staircase, a configuration that would allow a spacecraft to leapfrog from one world to the next using their gravity like celestial slingshots. This alignment would compress what should have been a 30-year journey into just 12. And when NASA realized what Flandreau had discovered, the agency pivoted its entire strategy and began quietly building 2 machines that would use this once-in-a-lifetime corridor to escape the solar system entirely. Voyager 1 and Voyager 2 were born from that cosmic window, built to ride gravity like a ladder and reach worlds no eyes had ever seen. But what no one understood at the time was that this alignment also placed the Voyager probes onto trajectories that would push them deep into the interstellar medium, into regions where the sun's influence collapses and only the galaxy's raw environment remains. The same alignment that made the Grand Tour possible also made this transmission possible. Voyager 2 launched on August 20, 1977. A modest-looking spacecraft wrapped in gold-colored insulation, powered by plutonium heat, and guided by computers that today have less memory than a digital watch. And yet, it became one of the most accomplished explorers in human history. It survived Jupiter's radiation storms, it survived Saturn's rings, it survived the eerie frozen deserts of Uranus. And it became the only spacecraft in history to visit Neptune, flying past its sapphire atmosphere and watching the great dark spots swirl beneath blue methane clouds. Along the way, it discovered new moons, rings, volcanoes, nitrogen geysers, extreme winds, and mysteries that astrophysicists still struggle to explain. And then, as its cameras were shut down, as its last images were stored on its aging tape recorder, Voyager 2 crossed the boundary where the solar system ends, the heliopause, and entered interstellar space. Since then, it has relied on the deep space network to whisper signals across a distance so immense it takes 18 hours for Voyager's message to reach Earth. But the story doesn't end there. Because as Voyager 2 drifted deeper, its power began to fade. NASA shut off heaters, switched off instruments, sacrificed non-critical systems one by one just to keep the probe alive. Even so, in 2020, the spacecraft fell silent for 7 months, vanishing into the void. And when NASA finally restored contact, Voyager 2 behaved in a way no one expected. Its data was inconsistent, its orientation inexplicably corrected. And then the first strange anomalies began to show up in its measurements, anomalies that are now resurfacing in the new transmission. Voyager 2 didn't just explore planets, it revealed entire worlds that rewrote science. When it reached Jupiter, it transmitted images of swirling storms and iridescent clouds larger than Earth itself. It watched lightning explode across Jovian nights, and its cameras caught Io erupting with volcanic fire, the first active volcanoes ever seen beyond Earth. These discoveries alone should have defined Voyager's legacy. But the probe wasn't done. At Saturn, it slipped through a gauntlet of icy particles, surviving impacts from ring debris moving at thousands of miles per hour. It flew past Titan and detected an atmosphere thicker than Earth's, hinting at chemical mysteries scientists still debate today. Then came Uranus, the coldest and strangest of the giants. Voyager 2 found rings, discovered 10 new moons, observed a tilted magnetic field, and glimpsed a world knocked sideways by ancient cosmic violence. After that came Neptune, with winds screaming at 1,000 mph, storms the size of continents, and Triton, a frozen moon erupting nitrogen geysers 5 miles high. All of these encounters built a picture of a solar system alive with violence and complexity, but they also taught NASA something else. The deeper you go, the stranger the physics becomes. And once Voyager 2 crossed the heliopause, everything the spacecraft observed, plasma, magnetic fields, particle density, behaved in ways scientists were not prepared for. And now, decades later, those same regions seem to be connected to the unexpected transmission. Before Voyager's cameras were shut down forever, Carl Sagan convinced NASA to turn Voyager 1 around and capture one last portrait. A mosaic of the inner solar system seen from 3.8 billion miles away. One frame in that mosaic contained our entire world. A tiny speck suspended in a sunbeam so small it could be mistaken for dust. The pale blue dot, an image that changed philosophy, astronomy, and human identity. And after that moment, the Voyagers went dark. No more photographs, no more color, no more glimpses of worlds, only sensors, instruments, and radio signals. Data transmitted in binary across the silence of space. Voyager became blind, but it did not become silent. It continued drifting outward, sending back reports of cosmic rays, magnetic fields, plasma density, and eventually the unmistakable signs of interstellar space. But as the years passed, those reports became more difficult to interpret. Instruments weakened, tape capacity shrank, errors increased. Manuals written in the 1970s became the only lifeline for the mission team. And then, after nearly half a century of travel, Voyager 2 began transmitting something that defied technical explanation, a repeating pattern, a faint structured hum, and measurements that did not match any known behavior of interstellar plasma. At first, it seemed like a glitch, then it returned, then it grew stronger, until finally in its most recent transmission something new appeared, something NASA cannot classify. Once Voyager 2 crossed Neptune and drifted into the cold beyond, it approached a region scientists had theorized about for decades, but had never directly observed. The heliopause, the outermost boundary of the Sun's influence. This is where the solar wind, a constant stream of charged particles blowing outward from the Sun, finally collapses under the weight of the interstellar medium. In simple terms, it is the border between our cosmic backyard and everything else. Models predicted a gradual transition, a soft fade, a gentle exchange of plasma flows, but Voyager 2 didn't find something gentle, it found chaos. Pressure waves slammed into the spacecraft. Charged particles surged unpredictably, magnetic fields twisted in violent, unexpected directions. The density of plasma jumped by a factor NASA did not believe possible. And for the first time in history, humanity tasted the raw, unfiltered environment of interstellar space. But the most disturbing part, the transition didn't behave the same way Voyager 1 observed years earlier. The boundary was thinner, sharper, more active, almost as if something had disturbed it, shifted it, or manipulated it since the first probe crossed. That asymmetry didn't make sense. And now, after the latest transmission, scientists are reconsidering the possibility that Voyager 2 did not simply cross a border. It crossed into something's territory. Once Voyager 2 officially left the heliosphere, it entered a realm of pure interstellar plasma, material that hasn't touched the sun in billions of years. NASA assumed it would be quiet out there, a kind of cosmic emptiness.